Good morning, kids. All right, this last section is on basically it's all full of word problems. Um, so I did look through it to make sure that just to pick and choose and see which ones I needed to do and not do. And there are a couple of challenging ones. The navigation ones, I think that are probably going to be the hardest. But when I looked back at what is going to be on your test, I think there's only 3 of them. Number 4, which is pretty straightforward, no navigation. Number 7, which again is super straightforward, nothing at all difficult about it. And then number 10, which is not navigation, but the figuring out the angles is maybe a little tricky. So hopefully that holds true on the test. But here we go. So question 1, a boat leaves the port and follows a course of north 78 east at 12 knots. And by the way, 1 knot is equal to 1 mile per hour. It's just a knot just tells you that it's on the water. 12 knots for 3 hours and 20 minutes. Then the boat changes to a new course of south 27 degrees east at 15 knots for 4 hours and 20 minutes. How far is the boat from the port? Suppose the boat becomes disabled. How long will it take a rescue boat to arrive if it's traveling 20 knots? And then what course should the rescue boat take? So I think the first thing we need to do is get a picture. So I'm going to draw it down here. So our first heading is northeast. So let's just say here's our port and northeast at 78 degrees. So that means this angle here is 78 degrees. They are going 12 knots for 3 hours and 20 minutes. So 20 divided by 60 plus 3 hours, times that by 12 knots, 40 miles is how far we went. All right. Then we go to a new course of south, which is down, east is this way. So southeast, so we're going a new course, and it is 27 degrees. So inside here is 27 degrees. Let me do that a little bit better. Four hours and 20 minutes. At 15 minutes, 65. Okay. How far is the boat from the port? So here's what we're trying to find. So I need an interior angle, which I don't have. I have a piece of an angle here. So is there a way to find this piece of the angle? And what we need to remember with navigation is these compasses, which I'm not sure if that's what they're really called, but these compasses are creating perpendicular and parallel lines. So this is parallel to this, which means if this is 78, then so is this. So 78 would go in here. So this entire angle would be 78 plus 27, 105. So we can use all cosines to find x. And so we get x is 1 decimal, so 84.7. Okay. If he's going 20 knots, how long will that take? So remember, your distance is equal your rate times your time. We know our distance is 84.7. We know our rate is 20 knots. We want to find time. So divide. And we get 4.235. 4 hours. Times that by 60, 14 minutes. And then what heading should the rescue boat follow? So we need to know what the heading of this line is. In order to know that, we're going to need to know what this piece of the angle is. Now I know this little piece will be 12. So if I knew this entire angle, I could subtract 12 from it and I would have what I need right there. Okay, so that means that we're going to do 65 squared equals 40 squared plus 84.7 squared. Cosine, we'll call it P. So I get 47.8-ish. Subtract the 12. 35.8. Now that is what is in here. That's here. But navigation is from south to east, so I need here. So 90 minus 35.8 is 54.2. So it'd be south 54.2 degrees east. So there you go. All right. This problem is almost exactly like the first one, so I'm just going to give you the answers. And anytime that if I do that and you need me to work it out, just message me because you know I will. Same here. All right, so this one is one that is supposedly on part 2 of your test. So we have a 46-foot point D. The cable is attached to the end of the boom at point B and to an 11-foot A-frame. So here's your A-frame. It's 11. I'm going to draw this over here. So this is B, this is A, this is D, this is 46, this is 11. That's what we got so far. Angle BDA is 81 degrees. Find the length of the cable to the nearest foot. Oh, that's pretty easy. So, law of cosines. X squared equals 46 squared plus 11 squared minus 2 times 46 times 11 cosine 81. And then you just put it all in the calculator. You should get 45.6. I don't know why it does that. Okay. 5. We got a public park. Angle rotation for each. How large should the angle of rotation be set at to keep the walkways dry and conserve water? So basically, we're finding the measure of each angle. So you just pick one. We'll find A first. 146.2 squared equals 119 squared plus 87 squared minus 2 times 119 times 87 cosine A. Do your law of cosine. You should get A is 89. And you're going to do the same for the other side. I don't feel like I need to go over that again. Okay. $60-foot square. Okay. To the nearest foot, find the distance between the pitcher's mound and first base. So we're finding this distance here. Be careful. We cannot assume that's 90 degrees. All right. Well, we can assume these are 90 degrees. So this would be 45. Yeah. So we'll call that X. X squared equals 60 squared plus 43 squared minus 2 times 43 times 60 cosine 45. Let's see if that works. 42.4 feet. Yes. To the nearest tenth of a foot, find the distance between the pitcher's mound and second base. So now we're finding this distance. I'll try something real quick. So the answer they have is 41.9 feet. But here's what I was thinking was, why couldn't we use this big triangle? Because this would be a right angle, making these 45s. And so then you could use 1 square root of 2, which makes this 60 square root of 2 long. Oh, maybe you can. I put in the wrong number. So then you could take 60 square root of 2 and subtract the 43 that you already have. Yeah, 41.9. All right, 7. This is really straightforward. You're given the 3 sides. You need to find an angle. Here's the angle that you're finding. So you guys know how to do that. Just use your law of cosines. Okay, the bearing from A to B. Oof, oofed. That's not any better. Whatever. North 85 east. So this distance, because it's from A to B. A to B. So this whole distance doesn't stop here. That'd be A to C. A to B is 85. Find the bearing from C to A. Which would be northwest. Shoot, southwest. And so we would need this angle right here. Which, if we had this angle, do a different color. If we had this angle, it would be the same as this angle. So if we figure out this and subtract 85 from it, we'll have the little piece that's left, which would then be this one too. All right, so yours could use law of cosines. So A is 21.99 or 22. So 85 minus 22 is 63. And so this is also 63. Bicycles to point A must ride to here. The two roads meet at 35. The distance from A to B, B to C, so that B total paved roads is 28 miles. If cyclists can ride 24 miles per hour on a paved road, but only 7 miles per hour off the paved road, which would be faster. So basically we need to find this distance and then use 7 miles an hour to see how long it takes. Because we know this distance is 28 miles. At 24 miles per hour means the time is 28. I think it's like 10 minutes. That was about 20 times by 60. Yeah, 10 minutes. So 1 hour and 10 minutes for paved. So it asks us that. Okay, so let's figure this out, which we're going to use law of cosines to do. So basically 10 miles. So 10 miles so that'd be 1 hour and about 26 minutes. So the rider should stay on the paved roads. I'm redrawing this so it's bigger. So this is 6 degrees. Which means this is 84 degrees. which means this is 84 degrees, which means this is 84 degrees. Okay, we have a triangle here, this is 60, a triangle here, this is 60, and we know the height is 150 for both sides. So the down length, so we're just finding this and this. So now to find this angle, we do 180 minus 84, which would be 96. And so you'd have 60, 96, and 150 to find x. And here you'd have 150, 84, and 60 to find y. You should get 167 and 156. Okay, got another hill with a 27 degree horizontal. We're even trying to find a cable is attached to the top of the tower and anchored uphill. Distance of 33 feet from the base of the tower. This is a 90-foot tower. All right, so same thing. This is going to be 90 minus 27. So 63, which makes this 63, and then use log cosines. You should get 81. All right, so might help if you had graph paper, but essentially what you're going to be doing is the distance formula 3 times. So you have to do the distance from A to B. You're going to need the distance from B to C, and then you're going to need the distance from A to C. Remember, the distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. And so from like A to B, you would do 4 minus 1 squared plus 4 minus 9 squared. From B to C, you would do 9 minus 4 squared, plus 8 minus 4 squared. And then from A to C, you would do 9 minus 1 squared plus 8 minus 9 squared. Get your 3 distances. Once you have the 3 distances, to do the perimeter, you just add them up. You should get 20.3. Then to do the area, use Heron's formula. Just remember, S is 1/2 A plus B plus C. And the area is the square root of S times S minus A times S minus B times S minus C. And you should get 18.5. And then do the measures of all the triangles. So you're going to have to do log cosines twice. and then you can subtract from 180. And you should get 51.9, 82.3, and 45.8. 13 is the same, so I'll give you the answers. All right, the truck leaves the intersection at an average speed of 54 miles per hour. 5 minutes later, a car leaves the same intersection and travels on a street that makes an angle of 100 degrees with the truck. If the car travels at an average speed of 68 miles per hour and the roads are straight, how far apart are the two vehicles 15 minutes after the car leaves the intersection? Okay, so essentially, here's your intersection, and here's your truck, and here's your car. You're already finding this distance, but you know this is 100, so we need to find how long this is. And we need to do in miles. So we need to find this distance first. So take your 54 miles per hour. The problem's talking about minutes, so let's change that to minutes. So now we got miles per minute, and this person has been going, the truck is going to be going a total of 20 minutes. So multiply 54 times 20 divided by 60. So we should get 21 miles. That's this distance. Now do the same for the car. But their car is only traveling 15 minutes. $17. And then you just use LOCO signs. So you should get 26.8. A to B, southeast. Okay, so put A up here. This is 80. B. Oh wait, that's not. More like this. So now I got another tower, C, north, west. So C must be down here somewhere. North, west, 25. 40. So we're trying to find this. And the bearing. So what makes this hard is we've got this line here cutting through our bearing. So we don't know this angle. We also don't know this angle. Same as here, like I know this little piece, but with this line here, I know the big angle, but I don't know the little angle. So let me draw another compass heading and see if there's anything that I could find. All right, so if this is 25, this little piece would be 25. All right, if this is 80, then this would be 80, making this little piece 20, and this is 90. So this whole angle is going to be 90 plus 25 plus 20. Whoa, 135. There you go. So now you have an angle, two sides to find this side. And you should get 64. Now the second part of the question says, find the bearing from A to C. So I need to figure out what this is going to be. I think the only way to do that would be to use your three sides to find this angle. And then once you have that angle, subtract it from 80. So you should end up with south 49.2 east. So when you do that, you should get 30.8 in here. Parallelogram. Okay, so use law of cosines to find this angle. Well, I don't feel like I need to do that. Then once you find that angle, you've got this angle. And then you draw this one, and you'd use this angle with these two sides to find that side. So there you go. All right, guys. When I get back home, I'll start working on the ones for the last test.